AI is pretty much everywhere you look now, right? It's on our phones, it's in our cars, it's definitely in the chatbots we talk to online. But have you ever stopped to wonder what takes a general, know-it-all AI and turns it into a real specialist? Well, let's pull back the curtain on that secret.
You see, the powerhouses behind these tools, these large language models, or LLMs, they don't start out as experts. They're trained on just massive amounts of data from the internet, and that makes them incredibly smart, for sure, but also really broad. Think of them like a brilliant new grad who knows a little bit about everything but hasn't really mastered any one thing yet.
And that kind of leads us to the million-dollar question. We see all these amazing AI tools, but what's actually happening under the hood? How does a general model get so sharp, so intelligent, that it becomes genuinely useful for a specific company or a really complex job?
Well, the answer in a word is specialization. To make that leap from a generalist to an expert, like a customer service bot that knows every single detail about a company's products, or a medical AI that can spot patterns in patient data, that base model has to go through some very specific targeted training.
And there are really two main ways to get this done, something called Retrieval Augmented Generation, or RAG, and the other is fine-tuning. The analogy here is perfect. RAG is kind of like giving the AI an open book test. It can look up answers from a special library in real time. It's fast, and it's great for information that's always changing. Fine-tuning, though, that's more like sending the AI to a specialized grad school. It's about deeply learning and internalizing a new subject.
So let's dive into that open book method first. RAG is a really clever framework. It doesn't actually change the AI's core brain, if you will. Instead, it just connects the AI to an external, always up-to-date database that it can check before it gives you an answer. And the process is actually pretty slick. So imagine you ask a chatbot, hey, what were our sales figures for the new product line last quarter? In a flash, the RAG system zips over to the company's private sales database, finds the exact report, and pulls out the key numbers. Then it hands your original question and that fresh data to the AI. And just like that, the AI can give you a perfect, up-to-the-minute answer.
And here's the really crucial part, especially for businesses: security. With RAG, a company's sensitive, private data never has to leave its own secure system. The AI model just gets a little peek at the relevant bits and pieces it needs to answer your question. For handling confidential info, that is a huge, huge advantage.
Okay, so we've got the quick open book method. But what about that other one, the grad school approach? Fine-tuning is a whole different beast. It's way more intense. You're actually retraining parts of the AI's core model on a brand new, specialized set of data. This actually changes how it thinks and gives it new skills. But here's the thing. Whether you're giving the AI a library or sending it back to school, both of these methods totally depend on one single fundamental thing to work. Any ideas what that is?
It's all about the data. I mean, this quote just nails it. High quality, relevant, super clean data, that is the single most important ingredient for making a powerful AI. It's the not-so-secret weapon that makes the difference between a brilliant model and, well, a total failure.
So when we say AI training data, what are we really talking about? Think of it as the custom-made textbook we give the model to study. It's a carefully chosen, specially formatted dataset that's designed to teach the algorithm how to do one specific thing really well, just by showing it tons of clear, consistent examples. And this brings us to what might be the oldest rule in all of computing, but it's never been more true than it is with AI: garbage in, garbage out. If you train your model on data that's messy, irrelevant, or just plain wrong, you're gonna get results that are messy, irrelevant, and wrong. It really is that simple.
Now, one of the most important steps in creating that good data is called data labeling. So, to teach an AI to recognize cars, you can't just throw a million street photos at it. No, you have to go in and painstakingly label what's a car, what's a truck, what's a bicycle. You are literally creating the answer key for the AI's textbook.
But here's a fun fact. You don't use all of your data just for the teaching part. You actually split it up. So maybe 80% of it is used for that main training. Then you take a separate 10%, the validation data, to check in and tweak the model as it's learning. And then, finally, you save the last 10% for a final exam to see how well the finished AI does on information it has never, ever seen before. So what exactly makes data high quality? Well, it needs to be uniform and consistent so the AI doesn't get tripped up by weird formatting. It's got to be comprehensive so it covers all the situations it might run into, but also relevant so it's not learning from a bunch of useless noise. And maybe the most important of all, the data has to be diverse, so the AI's view of the world is accurate,
not based on some narrow, biased slice of it.
But here's the catch. Real-world data is almost never perfect. It's messy. So before you can even think about training, you have to go through this super important and honestly pretty time-consuming process called data cleansing.
This means you've got to hunt down and fix some really common headaches. First up, simple duplicates. If the same piece of information shows up again and again and again, it can basically trick the model into thinking that one thing is way more important than it really is, and that can throw off its whole perspective.
Next, you've got outliers. These are data points that are just totally out of left field. Let's say you're training an AI on customer data to predict t-shirt sales. Well, a single multi-million-dollar order from a corporate client would be a massive outlier, and it could totally mess up the model's predictions for what a normal shopper might do.
Then you have to fix all the structural errors. Oh, this is a classic. We're talking about typos, random capital letters, or having USA, lowercase USA, and VUS all listed as different places. To you and me, it's obvious they're the same thing. But to an AI, it sees 3 totally different countries until you clean it up and make it all the same.
And finally, you got to deal with missing values. Just one empty cell in a spreadsheet can bring the whole training process to a screeching halt. So you need a plan. Whether that's removing that entry entirely or finding a smart way to fill in the blank. It's detailed work, but it's absolutely essential.
So what's the big takeaway here? It's this. All the cool, flashy, headline-grabbing stuff that AI can do, it all rests on this invisible foundation. The success or failure of a project comes down to the hard, painstaking work of collecting, cleaning, and preparing high-quality data. That is what makes all the difference.
And that leaves us with one last, really fascinating question to think about. We're building tools that can learn to be experts in pretty much anything. Law, medicine, you name it. So if the quality of the textbook is what determines the quality of the expert, what does it mean for our future when the most important textbooks in the world are no longer being written for us, but for machines?